to start working with multiplying fractions. Now, sometimes you'll have to multiply a fraction times a whole number, so we're going to look at some strategies for doing that. There are several ways to show the multiplication of a whole number and a fraction. Here's the number line model. One way to multiply a fraction and a whole number is to think about hops on a number line. The whole number tells how many hops to make, and the fraction tells how long each hop should be. For example, to find 4 times 2/3, imagine taking 4 hops, each 2/3 of a unit long, on a number line. Where do you end up? Right here, 2 and 2/3. Another strategy you can use is the addition model. You can use addition to multiply a fraction and a whole number. For example, to find 4 times 2/3, draw 4 models of 2/3, then add all of the fractions. This is often called repeated addition if you're multiplying. So 2/3 plus 2/3 plus 2/3 plus 2/3, you get 8/3, and then of course you're going to need to simplify that. 8 divided by 3 is 2 with a remainder of 2/3. So 2 and 2/3. I don't recommend this model because it works easily here when your numbers are smaller, but what if you're doing like 37 times 4/5? I mean, that would be a pretty big addition problem. You can also use the area model. Think of the problem 2/3 times 4 as what is 2/3 of an area that has 4 square units. Remember, 2/3 of 4 means 2/3 times 4. So you could draw 4 squares with each an area of 1 square unit. The rectangle has an area of 4 square units. Then divide the rectangle into 3 equal strips, so you're making thirds here, and shade 2 strips, okay, to show 2/3 of the area. The shaded area equals 1, 2, 3, 4, 5, 6, 7, 8, 8/3, okay? There's 8 small rectangles here. Each of them has an area of 1/3. So 2/3 of 4 square units equals 8/3 square units, which, if we simplify that like we did in the last problem, we get 2 and 2/3. You can also use unit fractions to find the whole, and I highly recommend this strategy. It works almost all of the time. A fraction with 1 in the numerator is called a unit fraction. For example, the fractions 1/2, 1/3, 1/4, 1/5, they're all unit fractions. 1/17, 1/9, okay? Unit fractions can often be helpful in solving problems with fractions. Let's take a look at an example. Alex collects sports cards. 70 of his cards feature basketball players. These 70 cards are 2/3 of Alex's collection. How many sports cards does Alex have? Well, we know that 2/3 of the collection is 70 cards. So 2/3 of something equals 70. Well, so I need to figure out what would 1/3 be, right? So if I took my I lost my train of thought. If I take a look at my parts and my wholes, okay, 2/3 means 2 parts out of 3 to make the whole thing. 2/3 is 70, so 70 is making up 2 of the parts. If I divide 70 by 2, I know that I can know how much 1/3 of the collection is. So 1/3 of the collection is 35 cards. Well, if 1/3 of the collection is 35 cards, all I need to do is multiply that by 3 to figure out the whole collection. Because remember, 3/3, 3 of those 1/3 groups would be the whole thing. So 3 times 35 equals 105. So therefore we know that Alex has 105 cards in his whole collection. So in this situation, I didn't know what the whole was. I knew the part, but I didn't know the whole. I was trying to find that out. So I had to divide by my numerator, and then I multiplied by my denominator. Let's take a look at another example. Alicia baked cookies. She gave away 24 cookies, which was 3/5 of the total she baked. How many cookies did Alicia bake? Well, we know that 3/5 of Alicia's cookies is 24 cookies. So 1/5 of Alicia's cookies is 8 cookies, because we take that 24, divide by 3. Now, the whole batch of cookies, which is 5/5, would be 5 times 8, because we got 5 groups of 8. So 5 times 8 is 40 cookies. Alicia baked 40 cookies. Pause the video here and complete journal page 259. I would like you to check your work. You can pause this and check your work and then resume. Now, continuing on with multiplying fractions. We were multiplying a fraction times a whole number. Well, what about when you multiply two fractions? Well, thinking about area can help. Let's say our question is, what is 3/4 of 2/3? So I have to think, how much is 3/4 of 2/3 of this rectangular region here? Okay, so this is my whole box. Here's how I can do this. I can shade 2/3 of the region this way. So I'm going to make thirds going in this direction, and I'm going to shade 2/3. So now I've shown 2/3. Now I'm going to take my other fraction, 3/4, and I'm going to shade it in a different way. So instead of going across like I did with thirds, I'm going to divide it going vertically here. So I'm going to divide it into fourths, kind of imagining that this part is not there right now. So here's my 1/4, 2/4, 3/4 that I shade, and they're 4/4. I'm not going to shade that part. Okay. Notice how I shaded it in a different way. Well, the part that is overlapping here, that's crisscrossed in both ways, is the answer. Okay, so I just look, it is 6 boxes out of 12 total boxes. So it's 6/12, or 1/2, of the whole region. Okay, pretty cool how that works out. I'm looking for the part that gets doubly shaded. So turn your journal to page 260. Now you have some problems to practice. They talk about paper folding because what they're really thinking is that you can do this with an actual piece of paper. Okay, and what we're drawing in the book here is just basically a picture representation of what you can do with the paper. If you want to try it with paper, go for it. That'd be awesome. You don't have to, but that'd be cool. Alright, so it tells us to sketch the folds in the shading and write an X on the parts that show the answer. So here's our first problem, 1/2 of 1/2. Now here's how we do this. We take the first fraction. It really doesn't matter what order we do it in, but take the first fraction. Divide your whole rectangle into whatever it is. So in this case, we're talking 1/2. Okay, so I'm going to divide it in 1/2 vertically. And then I'm going to shade 1/2. And I'm going to use like diagonal lines like this. And I want you to be in practice doing the same. Okay, notice how I'm going like in all the same direction. Okay, so there's 1/2. Now, this represents my first fraction. Now, I want to deal with my second fraction. Again, it's 1/2. This time, I'm going to divide it going horizontally. So I'm going to use the opposite direction. Okay? So, divided it in 1/2, and I'm going to shade 1/2. And when I shade this 1/2, I'm going to do my like diagonals in a different direction. You don't have to use a different color. I just to show you more clearly, but make your diagonals going across in a different direction. And now I'm shading 1/2 because my second fraction is 1/2. Okay, now here's what we're looking for. We're looking for the part that was double shaded. Okay, so you can see here that this part here was double shaded. All right, that's our answer. How much does this part represent of our whole rectangle? It is 1 out of 4 total boxes. So the answer is 1/4. Cool, huh? Let's try the second one. Okay, we've got 2/3 of 1/2. So my first one is 2/3, my first fraction. So I'm going to make thirds. I'm doing this kind of quickly because I'm running out of time here on my video. But, so here's 2/3, and I'm going to shade 2/3 of it. All in the same direction. Okay, now I have shown 2/3. Now I'm going to work with my second fraction, which is 1/2. I'm going to work in a different direction. So I'm going to divide it in half this way. I'm dividing my whole rectangle in half this way. And I'm going to shade 1/2. And remember, when I shade my 1/2 this time, I'm making my diagonal shade lines in the opposite direction. Now, we need to look for the part that's overlapping. Which parts got double shaded? And let's pretend that these are equal. They should all be equal, shouldn't they? But humans aren't perfect, so I didn't make quite equal. Okay, 2 of these boxes are double shaded. So 2 boxes out of 1, 2, 3, 4, 5, 6 total boxes. Okay, so the answer is 2/6. Or if you can see here that it can be reduced to 1/3. 2 divided by 2 is 1, 6 divided by 2 is 3. Okay, now, hopefully that technique makes sense. Go ahead and give it a try. Finish